Welcome to this video on the Automic Automation Azure Data Factory ADF integration solution. In this video, we will explain the Azure Data Factory ADF cloud integration and what it brings to the Automic Automation user community. Azure Data Factory is Azure's cloud ETL service, designed for scalable, serverless data integration and transformation. With Azure Data Factory, you can create scalable workflows to transform data, manage data pipelines, and ensure seamless data integration. For large enterprises, you can integrate Azure Data Factory with existing workflow automation solutions. To simplify the integration process, define your data pipelines in Azure Data Factory and schedule, and execute them using your enterprise workload automation solution. Integrating Automic Automation with Azure Data Factory allows you to run Azure Data Factory jobs in your workspace from Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating Azure Data Factory, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. Azure Data Factory processes can then be synchronized with all other environments routinely supported by Automic Automation. Azure Data Factory's role is reduced to execute the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the Azure Data Factory environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to run pipeline jobs. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervised processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of Azure Data Factory jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the Azure Data Factory endpoint and login data, and a job template designed to trigger Azure Data Factory jobs. Let's assume we're automating for 4 instances of Azure Data Factory. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create the Azure Data Factory jobs in Automic Automation for each corresponding process in Azure Data Factory. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in Azure Data Factory. We're able to retrieve the successive statuses and finally generate a job report. In Automic Automation, this job can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the Azure Data Factory integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. Azure Data Factory is a standard Automic agent. It requires at least 4 values to be updated: agent name, Automic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every Azure Data Factory instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the Azure Data Factory endpoint. Finally, we use the Azure Data Factory template jobs to create the jobs we need. We match these Automic Automation jobs to the Azure Data Factory jobs, reference the connection object, and run them. We're able to supervise the jobs, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the Azure Data Factory integration. The agent is included in the Azure Data Factory package, which we download from Marketplace. We unzip the package, which creates a file system agent /Azure Data Factory /bin that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcidx and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con or connection object, and the Azure Data Factory job templates. In our demo, we will create a connection object. Once we have established the connection to the Azure Data Factory environment, we'll create a run pipeline job. Finally, we'll execute and supervise this job. The Azure Data Factory console offers a variety of features accessible through the left navigation pane. From the navigation pane, select Author to view factory resources, including pipelines, change data capture, datasets, data flows, and Power Query. Navigate to the Pipelines section to see a list of pre-existing pipelines. Click a specific pipeline and you can view the stages. Lookup stage retrieves a single row or a list of rows from a data source. Wait stage introduces a delay or pause in the pipeline's execution for a specified duration. Copy data stage moves or transforms data from the source to the destination. Once the pipeline is triggered successfully, click the Monitor tab on the left navigation pane to view the pipeline status. Let's move on to the Automic system. Here, we create a connection object with specific inputs to connect to Azure Data Factory. We must enter the endpoint. This is the URL of the Azure Data Factory environment. We must then specify an authentication type. We have 3 options: the service principal type, the OAuth2 token type, and the token from file type. With the service principal type, you must define your Azure AD URL, a tenant ID, a client ID, and a client secret. With the OAuth2 authentication method, depending on the version of the OAuth2 authentication method you select, you must either define the resource or the scope. The OAuth 2 token authentication type requires you to specify a token, which is a bearer token used to log into the Azure Data Factory environment. The third type is the token from file authentication type, which requires you to specify the file in which the token is stored. If you are using a proxy in your environment, you can specify the proxy hostname, port, username, and password in the proxy section. Once the connection object is defined, you can create a run pipeline job. The connection drop-down list lets us select the appropriate connection object. Following the connection input, the job requires the subscription ID, which is a unique identifier for the resource group where the resources are located. Next, the resource group name parameter is the name of the resource group that contains the data factory. Then, the data factory name parameter specifies the name of the data factory where the pipeline resides. Additionally, we can specify the pipeline name. Next, the pipeline parameters include none, JSON, and file path. We can either type the JSON directly or provide the path to a JSON file stored on the agent machine. For this demo, we have selected file path. Everything is configured now, so we execute the job. Let's go to the executions view. It shows the list of executions in Automic Automation. As you can see, this is the job we have created and it ended okay. If you go to the details pane shows the remote status field, which tracks the job status in the target environment. The job has been completed successfully. The details panel displays object variables and pipeline run ID hash, which provides the intermediate request ID. Let's have a look at the reports. The report captures the final response we received. The agent log lists all the connection details, followed by the job inputs and execution logs. Finally, we see that the job was completed successfully. Make a note of the run ID ending with FDBF. We will use this run ID for verification in the Azure Data Factory instance. Let's check the file status in the Azure Data Factory environment. This is the job that we triggered and it has completed successfully. That wraps up the demo on how Automic Automation can integrate with Azure Data Factory to run, execute, and monitor pipeline jobs. Thank you for watching this video.